Great to be here with you. I also help direct something called the Center for Science and Culture at Discovery Institute, from which the next speaker you're going to be hearing comes from. And I want to just tell you a little bit about what we do and some ways that you might want to become involved and some resources that we might be able to provide for you. Our mission at the Center for Science and Culture at Discovery is exploring the evidence from the natural world that we're the products of intelligent design rather than simply a blind and undirected process. The work of our scientists and thinkers deals primarily with the scientific evidence and the conclusions that can be drawn from it. We have around 40 research fellows in fields such as biology, biochemistry, mathematics, physics, astronomy, and philosophy of science. People like Michael Behe, William Dembski, Michael Denton, Stephen Meyer, Guillermo Gonzalez, and Jay Richards. And actually outside the Center for Science and Culture, we have some notable people as well. Some of you may know the name Michael Medved. He is actually a senior fellow of Discovery Institute. And so is author George Gilder on economic matters. But the Center for Science and Culture at Discovery does basically four things. We promote research and scholarship, so our authors and fellows write lots of books, hundreds of articles. We fund a science lab under this called the Biologic Institute. So the first thing we do is really promoting scholarship and research. The second thing we do is sponsor and get involved in educational conferences and events. Last year, our staff and fellows spoke at over 100 events at colleges, universities, churches, seminaries, community groups, reaching more than 32,000 people in person. Now, one of our most important educational programs and events is actually a summer program. So if any of you are college students, I would encourage you to think about applying to our summer program. We pay all the expenses to bring you out for 10 days in Seattle. And I will say that although in the rest of the year, Seattle may not be as nice as some areas of the country, in July, it is a lot nicer than almost any other part of our country, if I do say so myself. We have two seminars, one for students in the natural sciences and the other for students who are in the social sciences. The social sciences and humanities and theology, that program is called the C.S. Lewis Fellows Program, and the first one on the natural sciences is also a terrific program, and the application deadline for this year is April 15th, so you actually have a few days still to do. This is for upper division undergraduates, juniors, seniors, and early graduate students. So there's still time to apply. If you want more information, at the Discovery table out there, there's actually little forms on it. But again, you could go online to discovery.org/SEM. The third thing we do is try to communicate a lot through the mass media, through videos, through documentaries, through talking with reporters, and our own online presence, Evolution News and Views, which now has an annual readership of about 500,000 unique visitors. And so that's a place that you can go to get updated on a lot of these arguments and evidence. And fourth and finally, we try to defend the academic freedom and free speech rights of students, professors, and scientists to really debate the evidence on scientific issues, especially relating to Darwin. And so that's something that we're involved in. Just one more thing before I introduce the speaker. When you came in, you may have gotten this special offer. I just want to highlight it. If not, you can get it at our table. We have a big book coming out by the director of our Center for Science and Culture, Stephen Meyer, called Darwin's Doubt, which talks about the explosion of animal life and the case for intelligent design. We are so enthused about this book and think it's going to be a game changer of the debate that we are offering pre-orders for it. It's going to come out in June. That's 43% off the cover price, plus free shipping, and plus if you do the pre-order here and you drop this off with Sam Wall out there or myself, we will ship you a free DVD called Darwin's Dilemma, which is on the Cambrian explosion, normally worth like $20. So if you are at all interested in the Darwin ID debate, this is your chance to get where it's going and get a great price and get a free DVD. Now, with all of that, Dr. Paul Nelson is a fellow with the Center for Science and Culture at Discovery and an adjunct professor in the Master of Arts program in Science and Religion at Biola University. He holds a PhD in the philosophy of biology and evolutionary theory from the University of Chicago. He is the author of numerous technical and popular articles on the Darwin intelligent design debate. He's co-author in particular of the Explore Evolution textbook, which examines the evidence for and against modern Darwinian theory, and is currently used in different editions in the United States, the United Kingdom, and South Korea. And we've just actually made arrangements. There was going to be a Polish translation as well. Dr. Nelson is featured prominently in several science documentaries, including Darwin's Dilemma Metamorphosis, which is a beautiful documentary on butterflies. And I'd encourage you, if you haven't seen that one, this is great to show your friends who might be agnostic. I just really encourage you to do that. And then upcoming, within the next month, there will be a new documentary called Flight, The Genius of Birds, and he is going to be featured in that. And so with that, I'm going to stop my introduction because I want you to hear the maximum amount from Dr. Nelson, who is a terrific and winsome speaker. Dr. Nelson.
It's a great pleasure to be here at Patrick Henry on this beautiful spring day. My wife and I in Chicago have been waiting a long time for spring, so I'm delighted that it's finally arriving. My subject tonight is to give you a critical analysis of Darwinian evolution, and we're going to do that in some detail, in fact, looking at this problem. How do you build animals where they didn't exist before? Can an undirected material process such as natural selection do that, or does the evidence require intelligent design? Now, I will get to that in about 10 to 15 minutes, but to get there, I want to do a little sort of intuition pumping. There's a view of intelligent design which says, from the skeptical standpoint, that it's just a new name for an old can of soup. Swap the label, maybe the marketability goes up a little bit, but really nobody is fooled. Now, I encounter this critique all the time in my professional work. People say, well, it's just creationism, relabeled for the 21st century. But really, Paul, nobody is fooled. Nobody is fooled, it's just creationism with a new label. Now, I want to challenge that because I would say that, in fact, inferring intelligence, reasoning that there was an intelligent cause involved in some event or pattern is something that every human being does. It's part of basic rationality, and it's not spooky. In fact, there's a well-established logic underlying these inferences. But to get you to see that, let's do some quick case studies, just to kind of pump your intuitions, because we're going to come back to this notion of design later in the talk when we look at the biological evidence, and I want your brains to be warmed up. So, this is something you do every day, as I indicated, and what you're looking for is the cause sufficient to explain some pattern or event. Causal sufficiency is what we want. We want the cause that can actually do the job. In his presentation, Dr. Lennox talked about abductive reasoning. It's a form of reasoning where you survey the possible causes and ask which one is the best, and that's what we'll do. So this may be a bit difficult for you to see, but this is the front page of the LA Times from March 31st, 2003. Those of you who were paying attention at the time know that one of the Iraq wars was going on. Now, we're going to look at this photograph here, which is the best, located in the best real estate in a newspaper. Above the fold, front page, left-hand corner. English speakers scan from left to right. So the editors have put this photograph in really the best spot in the newspaper. There it is. It's a dramatic picture. Now, a few days after this photograph was published in the LA Times, the photographer was fired, and I want to see if you can figure out why. Now, while you're looking at the picture, I'll tell you what it purports to depict. This is a British Marine outside Basra in southern Iraq, and he's telling these Iraqi civilians to stay down because at the time the photograph was taken, mortar fire was coming into the area. Now, see if you can figure out what's wrong with this photograph that led to the photographer losing his job with the LA Times. I'll point over here. Look at the curve of this man's back and his knee there, and the curve of this man's back, right behind the leg of the Marine there. Or that head right there, and that head right there. Actually, if you analyze this picture closely, and you can download the whole sad story of what happened here online, if you care to do it, there are an unusual number of identical twins in the lower left-hand corner of that photograph. And the reason they're there is that image actually never occurred as light entering the lens of a digital camera. These two did. And the photographer, probably using Photoshop or some other software, and you might be tempted to do this as well, I know I certainly would. He looks at this and he says, now, a man carrying a child bent over like that, that's a dramatic image. And that Marine with his arm up, that's a dramatic image. These exposures are probably only a second or two apart. And the photographer probably rationalized it and said, look, it's the same event, really. With a little manipulation, I've got a potential, possibly a Pulitzer Prize winning photograph. The problem is he was working in a war zone on deadline, and he did not notice that he reproduced at least 3 people twice in the lower left-hand portion of that photo. Now imagine that you're an LA Times subscriber, living in Brentwood. You go out, you pick up your paper, you're walking back to the house, and you see this. Now let's say you're an atheist, devotee of Richard Dawkins. Nevertheless, here is a puzzle in the world to be explained, and you want the best possible explanation for that puzzle. And if you go online, as I indicated, and read the story of what happened, the editors at the LA Times ran through all the possible natural causes for how that could have happened, and they rapidly exhausted them because there just aren't that many. What's the sufficient cause for that? A photographer who forgot what he should have remembered, namely that newspapers will not publish electronically manipulated images without informing their readers of that fact. So that's why he was fired. Now, think about this kind of pattern of reasoning, this kind of inferential pattern like a game show, okay? So behind that door, we're going to have a whole bunch of different puzzles that we're going to look at of a variety of different kinds of objects. And over here we have the solutions. So you're in the game show, you're called down to the front, and you can have box number 1. Box number 1 is filled with thousands and thousands of solutions of a particular form. Let's call it solutions of type X, okay? That's what's in box 1. Or you can have box 2. Now the interesting thing about box 2 is you get all of the type 1 solutions, all of these X solutions. They're all in there. If there is a solution of type X in box 1, it's also in box 2. But you also get the type Y solutions. Now, just on this bare bones description, nobody in this room would choose box 1 over box 2. Even if you never use or only rarely use the type Y solutions, it's still a better deal to take this because you're not losing anything. All right, keep that framework in mind. You're a curious human being. You want to explain and understand the world, and you want the greatest explanatory power possible for whatever puzzle pops up behind that door. So if we throw our curious photograph in there, and we look over in our 2 boxes, let's say the type X solutions are those that are ultimately derived from physics. As Dr. Lennox said, particles in motion, matter in motion. Type Y solutions involve an intellect or an intelligence or a mind, in some sense like yours. Well, you can see clearly the only explanation for that anomalous pattern there is the photographer's intellect, or in a certain sense, lack of intellect. I mean, he used his brain, but he didn't use all of it. In any case, type X physical solutions won't work. And here's the funny thing. If we did have a solution like that, let's say this poor photographer had a brain tumor, and he comes back to LA and he has an MRI done, and he says, I just couldn't help myself. And they look, and sure enough, he does have a brain tumor, and it's right in the part of his brain that affects voluntary action. He's off. He's absolved of the crime because there was a physical explanation that takes over where his will or intellect should have been operating. In any case, type Y is the one that will work here. Now, we use these kinds of inferences all the time. Everybody does. You couldn't get through your day without being able to say, this pattern had an intelligent cause, this one had a natural cause. We discriminate between them, and we do this independently of our philosophical views, our religious or theological views. It's just part of what it means to be a reasoning human being. And it's not spooky. Here is the basic distinction, which Dr. Lennox has already touched on. On the top, we have an event caused by intelligence, where intelligence is in an important way irreducible to physics. There's something about intelligent causation that does not collapse to a strictly physical story. On the bottom, we have events caused by physics, where the agent, the intellect, the mind in question is dissolved away. And this distinction between things that are caused by a mind and things that are caused by something without a mind, a physical process ultimately, or cause, is quite ancient. And it's not specifically tied to any particular religion. So here's a book I strongly recommend to the students here. The ones I've met already, just in the few hours I've been here, are incredibly literate. I was saying to your president something that I've noticed about a lot of homeschooled kids, that Western culture will pass through this generation via homeschooled kids. It's like the remnant of Western civilization that actually reads Plato and Aristotle and so forth. So this is a book you would enjoy. The point of the book, by David Sedley, who's a professor of classics at Cambridge, is that the debate between the view that mind is primary and the view that physics is primary is ancient. Hundreds of years before Jesus was born, hundreds of years before anyone walked the planet that you could call a Christian, Greek philosophers were in a lively debate about whether it made more sense to say that intellect was primary in the universe or physics. And so Sedley, in his introduction, says, I'm not going to talk about biblical authority, which figures prominently in the American creation-evolution debate, because it simply wasn't relevant to these ancient Greek philosophers. They did not respect or acknowledge the authority of the Torah, but they were using their minds to figure out the world. So this debate, this intelligent design debate, actually transcends any particular religion and really is something that belongs to humanity as a whole, really throughout the whole history of our species. All right, so let's look at some different puzzles really quickly, just to kind of pump your intuitions. Anyone who has studied mineralogy should recognize that. Nice hexagonal prism geometry. The chemical formula is SiO2. That's quartz. You can grow it. Watch manufacturers do that. They get big vats where they grow quartz crystals, because when you put a current through quartz, it oscillates with a very high frequency, nice and regular, and you can step that down and run a quartz watch with it. Now, in this case, one does the job just fine. We have a physical story that works perfectly well to explain the origin of that. And 2 does too, because as I pointed out, 2's got all the type X solutions there. How about that? Now that should be more challenging to you. Beautiful little symmetrical black glassy object kind of looks like a button. Does anybody recognize what those are? Anybody? They're tektites. Now, when tektites were first discovered, there was a long, decades-long debate in geology about whether they were natural or artificial. And you had very good scientists on both sides of the question. I've done polls in professional scientific audiences. I've shown this slide. And about half or more of the audience who does not know what tektites are will vote for these as being artificial, because they look like a little glassy button that someone formed. Now, in a case like this, it's unclear whether box 1 or the type X solutions wins hands down. You might want to keep this as a live possibility given the ambiguity of the evidence. Well, it turns out that there's a really pretty good physical story for how tektites formed. In a meteoritic impact, molten globules are thrown off after the impact, and as they fall through the atmosphere, thrown off and fall through the atmosphere, they cool, and the air pressure coming up underneath forms that beveled edge, such that when they land on the ground, you find them with that nicely shaped button form. At this moment, in 2013, that is the leading and probably the best explanation for the origin of tektites. The point is, During their discovery, or during the period that they were discovered and people were trying to sort this out, artificial or intelligent causation was a live possibility. It needed to be there in the toolkit because the evidence was unclear. How about that? Anybody study paleoanthropology here? This is probably not the best view of what this is. A better view would be end on. It's a hand axe formed from flint or some other stone like that. Would fit very nicely in your hand, well balanced, with a sharp beveled edge for doing things like stripping hide. Now, I am not trained in paleoanthropology or paleoarchaeology. I could be out walking in a field and step right over that. And an archaeologist would reach out and grab my arm and say, "Do you realize what you just stepped over? That's a hand axe. That's a valuable artifact." In this case, type X is not going to work. The true and really only causally sufficient explanation for the origin of that is at least one intellect, at least one mind. And here, of course, there's no way you're going to get that arrangement of pigment without Leonardo. It's just absurd to imagine anything else. Well, the point of these examples is that any scientist, irrespective of their philosophical outlook, and I would say this even if I were an atheist or an agnostic, should have this kind of toolkit when they come to confront the puzzles of the universe. Because we do not ordinarily collapse intelligence into natural causes. Now, there's a program to do that right now, a sort of reductionistic, materialistic view of human agency, but it will never be successful for lots of reasons, if no other reason than the way that practical realities of human existence. The point is, both of these kinds of causes belong in the toolkit of science, and the real question for us is what are going to be the limits on our freedom to use this kind of cause should the evidence call for it? Now, a skeptic might say, "Paul, these are just examples from everyday life." Well, let me give you one to point out that the integrity of natural science itself depends on our ability to detect intelligent causation. Where if you did that, if you excluded intelligent causation from your toolkit before the evidence had a chance to speak for itself, you would in fact do damage to the practice of natural science itself. So here's the story. Hendrik Schoen was a young physicist at Bell Labs who was on his way to a Nobel Prize in solid-state physics. He had a string of high-profile papers in very, very good journals, the best journals in the world, that were front-page news in the New York Times. The problem is no one could replicate his results, which is bad. That's bad. You know, if nature herself is producing some phenomenon and you discover it, you should be able to give me, as an independent investigator, your protocols, your methods, and so forth, and I should be able to replicate that result. You don't need to be there for it to happen. So even though Schoen was said to have golden hands and got these remarkable results, no one could replicate them. There he is. Excuse me. This didn't actually happen. The university in Germany that awarded his PhD tried to take it away because the crime he committed against science was so egregious they were embarrassed. He actually fought them in court and was able to keep his PhD. But you can see that it was a pretty severe thing that he did. Now, Bell Labs was worried because these results could not be replicated. So they formed an investigative committee, and they took all his papers and kind of laid them out one next to each other analytically. They were looking at them and comparing them. As soon as they did that, they noticed some very funny patterns in his results. And you can see here in the headline from the New York Times, 2002, there were some similarities that were hard to explain. Now, what the Times did is they took two figures from two of his publications. This one from Science in November 2000 on a light-emitting transistor. Now this figure is supposedly experimental data that he's gathered. And this from Applied Physics Letters, that journal, in the next month, December, on a new organic transistor. Now you'll notice that these curves are largely identical. They're not entirely identical, but they're largely identical. What's really suspicious, though, is the noise is identical. This kind of bumpy line, you see it blown up here, in a physics experiment is ordinarily produced by the fluctuations in the instrument itself. And there's an associated small probability with that bumpy line that's very, very, very small. Now, the Times has taken that portion of that curve and that portion and blown them up here, and you can superimpose those. They are more similar than if I asked you to sign your name 5 times on a sheet of paper. There'd be more variability in your signatures than in those 2 lines. Once the committee saw that, his career was over, because there is no physical explanation why the noise should reproduce and form those identical bumpy lines. And again, you can go online and you can actually download the report from the investigative committee. It's like a 250-page PDF, and read what they found. And what one of the committee members said is, the only way that this can exist is he faked those diagrams. Again, using his intellect by his deliberate intent. There's no physical cause for that. So if we put Schoen's figures behind our puzzle door, to maintain the integrity of science itself, we need to be able to say those patterns were not caused by any physical mechanism. They were caused by something like us, something with a mind, namely Hendrik Schoen. All right, let's give the skeptic a chance again. The skeptic says it's all intelligent causation of Homo sapiens. Nobody doubts that. No sane person doubts that human beings can bring about certain patterns like this. Well, let's turn the temperature up philosophically. We'll grab that knob on the philosophical oven and crank it around to broil. There's Jill Tarter. She is the real-life model for the Jodie Foster character in the movie Contact, which I'm sure many of you have seen, based on a Carl Sagan novel. And when this photograph was taken, published in National Geographic, she was in Puerto Rico at the Arecibo radio telescope, a very large radio telescope there, and she's testing software. It's 3 a.m., okay? This is my view of the search for extraterrestrial intelligence. At 3 a.m., I can tell you I would have been asleep for about 4.5 hours at that point. But it's an important question to ask. Are there minds, is there intelligence elsewhere in the physical universe that we could detect? And what they're doing here is running pattern detection software. Now, I know you can't read it here, but this is what she says in the caption. They being, whoever might be out there. Now, why would the digits of pi be obvious? Of course, that's not the first thing they're looking for. The first thing they're looking for is a narrowband radio transmission that would have to be extraordinarily powerful to reach us, even from a planet or a nearby star. It would have to be very, very strong narrowband radio signal. But if it were carrying the digits of pi, that would be obvious. There's the first 500 of them. Because pi is a mathematical object. There are web pages where you can go and you can put in your phone number and it'll tell you where your phone number is in pi. But not with your area code. Even though pi has been solved out to a very, very, very large number now, it's a very large object, it's still not big enough to have your phone number plus your area code. Although within the lifetimes of people in this room, as the digital solution expands, the decimal solution expands, it will be there. But you would not need to see very much of this at all coming in on a radio carrier frequency, and you could open the champagne. Because mathematical objects, like the circumference or the ratio between the circumference of a circle and its diameter, universally in our experience are produced by intellects. Now think about what we would know about the cause of that. 2 very slender facts. It, whatever it is, can grasp mathematical relationships, and it can manipulate the electromagnetic spectrum and produce a powerful transmitter. But they could be blobs. They could be, sort of gaseous beings. Their biology would be totally unlike us, but we would have good evidence to indicate there was an intellect out there at the other end of that signal. So you can do this indefinitely. You can push the design inference and push it and push it and push it and move it away from Homo sapiens, and it's still perfectly rational. Jill Tarter is an atheist, but her research program would be dead in the water without her ability to open that puzzle door See that and say intelligence. All right. That's not why we're here tonight. None of this would bring you here tonight. We're here tonight because the intelligent design research program thinks there's evidence in the history of life pointing to an intelligent cause. And that really cranks the temperature on the philosophical oven up to 800, 900 degrees. Because if there was an intelligent cause for the first cell, or for the first animals, or for the origin of Homo sapiens, it wasn't a member of our species. That's what brings us here, and that's what really makes this challenging. So you might have someone say, I've got no problem with the SETI research program. It makes sense. Something could be out there. Who knows? Let's look. Or, of course, Stonehenge was built by Stonehenge makers, druids, whoever they were. That's rational. That doesn't scare me. This does. That's a protein complex found in every cell in your body that makes proteins. It's a nursery for baby proteins. It's called the chaperone. That's its generic name. In this central cavity, this large complex isolates newly formed proteins to allow them to fold in the very crowded interior of cells. I always thought that would make a nice stained glass window. Or pandas, or Richard Dawkins. He'd be happy to be up there in that company. These are biological objects of enormous complexity and sophistication. I think their features point to design. But again, as I point out, now we've got something that's really entangling philosophy and theology and a lot of other things that make people nervous. So that's why we're here. And what Dawkins would say is, we don't need to be here, Paul, because natural selection has done all the designing that needs to be done for those biological objects. In fact, he says it provides a mechanistic causal account of how living things came to look as if they had been designed for a purpose. So there's no need to invoke a designer because we have a perfectly adequate, blind mechanical process out there to do the job. Well, that's the claim we're going to challenge in the next 20 minutes or so. But let me point out that this view is very widely held. In fact, I would say it's orthodoxy in modern biology. Ernst Mayr, who had a long, distinguished career at Harvard, pointed out that the core of the Darwinian worldview is that natural selection replaces the designer that was there for William Paley or for Isaac Newton, or even for Charles Darwin himself as a young man. When Charles Darwin set sail on the Beagle, 22 years old, if I remember correctly, he was an Orthodox Christian, read the Bible on board ship, used to argue with the sailors about the accuracy of the Old Testament. That wasn't the view that he held in 1859. At that point, natural selection had come to replace an intelligent designer for the origin of the complexity of life. So let's challenge that view. Does natural selection do the designing work that Dawkins and Mayr and most evolutionary biologists claim that it does? And the puzzle we're going to look at is the origin of animal body plans. These are the basic architectural differences among the animals that you come to recognize even as a very young person. My older daughter is studying marine biology at Brown, but when she was, 4 or 5 years old, and we would go to Southern California to the tidal pools at Laguna Beach at low tide, she could distinguish in a echinoderm, like a sand dollar or a starfish, from an arthropod. They just didn't have the same overall architecture. And that's what we really want a theory of evolution to do for us, to explain how these basic differences came to be. So here's a little worm, very, very small. It's about a millimeter and a half long as an adult, only about 1,000 cells. Its entire genome has been mapped. Its complete cell lineage has been worked out. Biology knows a great deal about these little guys, C. elegans. Let's compare them to another system. Something is not... Oh, there it is. Fruit flies. If you have overripe bananas, you may often see these guys buzzing around your kitchen. Again, a species about which biology has learned a great deal. Again, its complete genome has been mapped. Its developmental biology is well understood. Or the purple sea urchin. you can see they don't have the same overall form. How did those differences come to be? That's the question we're going to ask. Now, if natural selection was the causal process responsible for the origin of those basic differences, we should be able to see it in action. First, by looking at the logic of natural selection itself, and then asking what kind of evidence does the theory require. So for the next 5 to 7 minutes, we're going to be good evolutionary biologists, look at the logic of selection, and then we'll strictly apply it. We are not going to use it as a magic wand. Natural selection is a real theory. It's a real process, and as theory and process, it makes strong demands on you as investigator to provide the right kind of evidence. So, the formulation that we're going to look at in a little detail is expressed as a conditional. It starts with if. In other words, if the following conditions are satisfied, natural selection will occur. So the first one is variation. We have to have differences. Differences all the way from the fundamental molecular level on up to the behavioral. Just look around this room at the people who are here. You'll see all kinds of differences just within Homo sapiens. Those will be the raw materials. So we have differences here among tigers. And given this projector, you can barely see him. He's like a ghostly Casper the Friendly Tiger over there. He's got no stripes. But he's a tiger. He's just kind of missing out in the stripe department. You can see there's variation there in the coat color and pattern of those tigers. Here are some stickleback fishes. Again, all within the same species, but you notice that there are differences among them. Or ladybugs. Or, within Homo sapiens, as I indicated, tremendous variety of differences in height, body mass, hair color, eye color, you name it. Those differences will provide the raw materials for natural selection if they make a difference to the number of offspring that you leave. So let's say that tiger who's all white, he looks kind of pathetic, but boy, does he get on with Mrs. Tiger or the female tigers. And sure enough, next generation, a lot of little white tigers running around without any stripes. Second condition then is the variations you have should make a difference in the number of offspring you produce. Well, that's not all you need. There's a third leg to the stool. Well, here's a little cartoon that shows you natural selection in action for a very simple single-celled eukaryote like yeast. So we've got an orange trait and a yellow trait, and let's suppose we introduce a selective condition here. Maybe it's a toxin indicated by this black bar that favors the yellow condition, and we maintain that selective condition, leave it there in the environment such that there's a real shift over time in the demographics of the population as a whole. The orange trait's gone at this point, and yellow has come to dominate the population completely. That is natural selection in cartoon form in action, and it's perfectly real. My wife is a pediatrician in Chicago, and during her training, she was advised to tell patients, in fact, there were posters that the American Academy of Pediatrics wanted doctors to put up in their waiting room. Don't expect to go home today with an antibiotic, because lots of us abuse antibiotics. We take them until the symptoms go away, let's say for 5 days, when the prescription calls for a 10-day course, and we put the rest of the pills in the medicine cabinet. The problem is bacterial populations are very large. They have a lot of standing variation, and if you do that, the next time you need to kill that strain of bacteria, they'll say, oh, I've got a plasmid for that antibiotic. Boy, I'm going right around it. We are losing in the race between pathogenic bacteria and antibiotics because of the reality, in part, of natural selection. There are some other complicating factors that I won't mention, but natural selection is a real process. I'm not denying that. The question is, what does it do? Anyway, that's what that cartoon shows. Our third condition is very important, and we're going to focus on it. You've got to be able to pass your variations on to the next generation. If you can't, they are invisible to natural selection. So you've got to be able to transmit those variations to your offspring. But if conditions 1, 2, and 3 are satisfied, natural selection will occur. In fact, you can't avoid it. All right, so there's our formulation. Just to remind you, these are the three legs of the stool. These conditions are jointly necessary and sufficient for natural selection to occur. If you've got them, it's going to happen. You can count on it. Now, keep this in mind, because when we come to the problem of the origin of animal form, it turns out, I'll give you a little preview, that the variations required to change animal form in a dramatic way, as evolution requires, are enormously destructive to animals. And it becomes hard to see how those variations could have been transmitted given their destructive quality. All right, a little poke at Professor Dawkins, or really, I shouldn't pick on him, any evolutionary biologist who says that natural selection explains what we see. The fact is, it doesn't. And here's how you can prove this to yourself. Just as an exercise in library research, pick any complex system of interest, the nervous system of chordates, or the gut of an echinoderm, any interesting complex system in any animal. Go to the biological literature and try to find the step-by-step scenario using natural selection by which that trait came to be. And I'll tell you what you'll find: nothing. Nothing. Natural selection is the most oversold mechanism in the history of biology, or I would say really the history of science. The actual evidence that's accumulated in 150 years since the origin is negligible compared with what natural selection actually has to explain. So when Dawkins says something like this, it's really not true. In fact, if he were here tonight, I would say, let's pick any system, Dawkins. You can pick it. And you know what we'll do? We will go to the PubMed search engine run by the NIH, and we will look for the detailed explanation. And he knows, and I know, that it's not there. So, oh, come on. I'm pushing the button, come on. All right. This is well known among evolutionary biologists. It's kind of a trade secret of the field, in fact. For a long time, I was just a little kid in Minnesota growing up when this happened, the Wistar Symposium in Philadelphia. But even at this point, at the height of its hegemony, in the mid-1960s, when the theory was most popular, people like Conrad Waddington, an English developmental biologist very involved in developing the theory of evolution in the 20th century, acknowledged that the real guts, what he calls the real guts of evolution, which is how do we come to have horses and tigers and things, is left outside the mathematical theory. And by that he means the expression and the equations in terms of population genetics for the basic operation of natural selection. One would expect that if natural selection could really do the building work of building horses and tigers and things, that you would find it there in the literature. But at that time and today, it's not there. And in fact, this is pretty well known. This problem is unsolved. It was unsolved for Darwin. It's unsolved today. And in the next 10 minutes or so, or 15 minutes, I'll explain to you why. Now, here are some more body plans just to show you some of their variety. As I said, my daughter, when she was young, could pick out a crab and distinguish that from an echinoderm with a five-fold symmetry. We're in this group here, the chordates. But you can see there's a lot of diversity of different kinds of architectures here. Now, according to textbook theory, all of these different architectures had a common ancestor in the Cambrian explosion. A form, this is two ways of drawing it here, called Urbilateria. That's just a fancy name for the original bilateral animal. We're bilaterally symmetric by and large. If we put a line down the middle of us, I've got an arm here, an eye, and so forth, even though our viscera are not. My heart's on my left, my spleen, I think, is over here. I should know that. It's in there somewhere. But you can see, like this trilobite, you put a dividing line down the middle of it. It has bilateral symmetry on either side. Here's an early chordate, actually an early vertebrate. Some of these groups are extinct. They don't have any modern representatives. The point is, all of these different architectures are thought to have had a common ancestor that was itself an animal. Now, this is entirely hypothetical. There's no fossil evidence for it. It's a hypothetical construct to tie together what are, in fact, very different ways of making a living as an animal. It's well known, again, within evolutionary biology, that there's no Darwinian account for how that happened, how those different body plans came to be. So I'll give you just a couple of examples. Wallace Arthur is an English developmental geneticist that I met in the late 1980s when he came to the University of Chicago on sabbatical. And at that time in his career, he was becoming increasingly disenchanted with textbook theory. So in this publication, he said, look, there's no Darwinian story for how body plans came to be. And this is the Linnaean binomial for the famous peppered moth of England, which many of you, I'm sure, studied in high school biology. There it is. A classic example of natural selection in action, where industrial pollution changes the color of the environment, darkens it, such that the dark-colored morph here is well camouflaged, I think you would agree. The light-colored one is saying, hey, bird, you want lunch? Here I am. You can't miss me, you know. So what happens is you get a shift in the population as a whole until the English cleaned up their factories, pollution went down, and again the population shifted back because the dark-colored morphs weren't so well camouflaged. I mean, it's a classic example. Now, Arthur looks at this and he says, yeah, that happens, but that doesn't explain where the moth itself came from. Differences in the amount of pigment in a moth don't explain how you build a moth wing or the moth and basic moth anatomy. We have qualitative distance or difference here between these phenomena. And in fact, he's become much more outspoken since this time. He said, in the end, we have to admit we don't know how body plans originate. Wallace Arthur says, I want to know where the moth came from. That's what evolution needs to explain. And if it doesn't, it's missing the boat. Eric Davidson, who is featured prominently in Steve Meyer's new book that I hope you'll get when it comes out in about 2 months, Darwin's Doubt. Eric Davidson is a developmental biologist at Caltech, and for the past 20 years in his career, he's been increasingly outspoken about the failures of textbook theory. So in this paper a few years ago, he said, what we see, the small changes that we see when species diverge, are not good models for how the body plans came to be. Again, there is this qualitative difference between the small-scale variation and what we really want to explain. He says, they're like apples and oranges. Well, you can trace the problem to the origin of textbook theory itself in the 1930s. At that time, it was an open question whether micro or small scale and macro or large scale evolution were equivalent. And the early neo-Darwinians, like Theodosius Dobzhansky at Columbia, in his classic work in 1937, Genetics and the Origin of Species, he said, the only way we're going to understand evolution is if we make an equivalence between the two. Because evolution, on the grand scale, takes place over geological spans of time that we cannot observe. So the only way to make progress is to make an equivalence between micro and macro evolution as a working assumption, and we'll push ahead with that as our basis. But he's worried about this. He says, it could be wrong. Oh, there we go. He says he's going to put a reluctant sign of equality between macro and microevolution, and we'll use that as our working hypothesis. Now, this is what science does, and I wish to stress that I am not denigrating evolutionary biology tonight. Science is based on fallible inferences. If you're afraid of making a mistake, get out of science. The greatest scientists in history made spectacular errors. It's part of the cost of doing science. So I'm not indicting him for failing here. He made a hypothesis, he pushed it ahead, but it turned out not to be true. But that's what we do in science. And I want to stress that that's part of the practice. So here's his picture. Now you can, if this is yeast, 10 to the 3 generations, you can watch that in no time at all. Even for Drosophila, you could see that. You could directly observe this as a biologist. Your starting population is here, time runs this way, you observe variations arising, and you extrapolate. You say, just let the raw materials of variation accumulate, let natural selection operate, and what you get is increasing divergence. So if your initial population for some character A was distributed here, With the passage of time and enough variation, you might see something arising like C that you would not have expected. Genuine novel evolution. So that's the picture that Dobzhansky has in mind, and what he's saying is, all we need is enough time and enough variation, and let the engines of evolution run, and we'll build body plans. That's the picture, and that has now turned out to be false. Within evolutionary biology itself, it is known to be in trouble. In fact, John McDonald, a geneticist in Georgia, at Georgia Tech, has called it a great Darwinian paradox. He puts it this way: the last 20 years of research on the genetic basis of adaptation have led us to this great paradox. Now, this was published when I was a lot skinnier, and I mean a lot skinnier, like 50 pounds, and I had all my hair. I was a kid. I was like the people in the back row up there. You're not kids, really, but pardon the expression. 30 years ago, a generation ago, this problem was already identified and known, that the small-scale variation seen in a Drosophila breeding cage was insufficient to explain where the fly itself came from. Now, let your philosophical radar turn on a bit here. How could an unsolved problem persist for so long within a discipline? There's a philosophical answer to that we'll come back to at the end if we have time. But let me show you where the paradox arises. It's at the intersection of three ways of thinking about biology. One is what we know from our study of animal development. There's a great deal of knowledge within that circle. The other, or one of the others, comes from the theory of common descent, namely the theory that all animals have a common ancestor. Now, this might not be true. I need to make that caveat. I myself am skeptical of this theory, but it's part of what generates the paradox. And then the last element in the paradox is the theory of natural selection itself. So when these three parts of biological understanding intersect, right here in the middle is where the paradox pops up. And it's a three-point argument. Here's the first point. This is what we know from development. All animals, well, not all, most animals, there's the purple sea urchin, start their life as a single cell, the fertilized egg. And from that cell, there's an unfolding arborescence of decisions, developmental decisions. So that egg divides to its daughter cells and so forth, and what happens is you get increasing specialization of cell types and tissues, eventually building the reproductively capable adult, the sea urchin here. Okay? The earliest stages in this process, back here, determine what follows because of the structure of this unfolding tree of decisions. The early decisions carry a much heavier responsibility than ones further downstream because the number of cells that they affect is much higher. The mutation occurring here may affect only a few cells in the adult, whereas one that's expressed back here may affect all of them. All right, what do we know from evolution? Well, to change that body plan of that purple sea urchin, or really of any animal, if you want to change its overall form, you've got to start back here with mutations expressed early in development because, after all, that's where the body plan is put in place. Think about it like the process of car manufacturing. If you want to change from a four-wheeled vehicle to a three-wheeled vehicle, you're going to have to modify your assembly line right at the beginning when the automobile frame is put in place. In an analogous fashion, that's how development works. If you want to modify the form, macro-evolve it, you've got to start here. Now, here's where the paradox comes. Those kinds of mutations are the ones least likely to be tolerated by the embryo because their bad effects cascade downstream and typically destroy the developing organism. That's the paradox. The very mutations you need for macroevolution to occur are the least likely to be tolerated by any developing animal. This problem, this paradox, is unsolved by evolution, but it's been known for a long time indeed. In fact, part of the knowledge that generated the paradox won the Nobel Prize for Christiane Nusslein-Volhard and Erich Wieschaus working in Germany in the late 1970s and early 80s, and they won the Nobel Prize in 1995 for very thorough experiments in Drosophila where they systematically mutated fruit flies in a form of reverse engineering. So if you want to understand how to build a fruit fly in terms of its development, one way you can get at that is just continually perturb this process and look at what the downstream consequences are. Break the embryo in 100,000, 10,000 different ways, look at what the consequences are, and then work your way backwards towards what's needed. So that's what they did. They induced thousands and thousands of mutations at different points in that developmental pathway, looking at the consequences. Then reverse engineered it and said, well, if you want a fruit fly at all, you're going to need this protein expressed at this time and so forth to build that fly. Now, this is going to be a little hard to see, but I'll show you. This is a figure from their Nobel Prize winning paper, and you've got 4 columns here. Each has 2 elements in each column. On the left-hand portion of the column is the normal form of the larva. That's the maggot of the fruit fly. And you can see there are 4 of them here. And then on the right-hand column is the mutant form. Now, some of these are very truncated. Whole sections of the normal larval form have been eliminated. Others are closer to what you might see in the wild, but they're all dead. They're all dead. Now, you can recover these mutant embryos and score where the mutations are, and again, work your way backwards, and you can say, look, if I want all of these sections to form normally, I'm going to need whatever gene was mutated in this embryo to be in its normal form. What's remarkable about their results, and Wieschaus was asked about this at a scientific meeting, is the mutations that would have been of interest to macroevolution, in other words, radically modifying the form of the fly, they were all dead. And he said, and yeah, they're all dead and you can't be more dead. Dead is dead. And the next question that was put to him is, well, where are the mutations that are relevant then for macroevolution, given that the ones that you induced all destroy the fly? And he said, well, we don't know. It was an open puzzle. It's not hard to understand why this should happen because of the way that development is structured. If you're putting your body plan in place here in the fertilized egg, and then you've got this expanding network of decisions, mutations that occur here are overwhelmingly likely to be destructive because they would affect so many cells. So let's say we have a mutation that's expressed here, very late in development. It might affect only a relatively small number of cells in the adult fly. One back here is going to take the whole system down. But as I pointed out, it's the mutations back here that are needed for macroevolution to occur. The problem, as I pointed out earlier, is that if you're going to change the global form of an animal, you're going to require dramatic mutations expressed early in development. Yet, universally, in our experience, those kinds of mutations are destructive, enormously destructive to animals. Ann Gager, who's a colleague of mine at Discovery Institute, Ann and I have compared this to a magic bridge. So here's a deep chasm. Let's say it's 1,000 feet deep. There's a bridge across it, and the bridge is magic in the following sense. Be right at home in any Indiana Jones movie. You start over here on the left, and as long as you keep walking towards the right, don't stop, don't look over the edge, don't turn around. As long as you keep walking unidirectionally towards the other side, the bridge will be there beneath your feet. The minute you stop, the moment you stop or look over the edge, the bridge disappears, and you plunge into the chasm. Now, in a remarkable way, animal development is very much like that. Once that egg is fertilized and divides, and let's say it's heading over here to be a sea urchin or a fruit fly or even little C. elegans with its 1,000 cells, that process has got to continue and can't stop. And you can test this for certain species by putting in a chemical that arrests mitosis, that it stops cell division. And the embryos are very unhappy. And they will tell you, they will die, because they're somewhere here. On the bridge, they need to keep walking. They need to keep going and continue to develop to get over here. Now, the puzzle for natural selection is reproductive capability is way over on the right. In our case, in Homo sapiens, reproductive capability doesn't come online until you're 13, 14, 15 years old. So not only do you have to get across the bridge to be an 8-pound baby, you've got to keep walking, for another 10, 12, 14 years until your gonads come online. It's only when you are able to make copies of your genes that natural selection can see you, so to speak, if I can personify that process. So how did natural selection build that bridge when one of its essential conditions is way over here for animals? Again, a puzzle that's never been solved. Well, I want to take some questions, and if we're going to stay on schedule, I should stop here. I actually have about another 20 slides, but there would then be no time for questions. So why don't we take some? And if questions come up about the remainder of the material, I can advance to those slides.
Thank you, Doctor. I very much appreciate what you guys do at the Institute. Continue to pray for you guys. Keep it up. That last argument was great. I used two that are similar to that. Since evolution has to be universal and there's thousands of species, and there had to have been hundreds or thousands of intermediate examples of each of these thousands of species, could they just show us one fairly complete fossil remain of any species? And the other one is, when you look at the strength of hydrochloric acid in, say, the human stomach, and the buffers that are required to balance that, that alone disproves that evolution could be real.
Let me take the second part of your comment first. I didn't present it in this talk. It's actually in other material, but it's very funny when you think about the digestive system. Probably most of you had some kind of protein with your dinner tonight. Pepsin is a digestive enzyme that your stomach secretes that's really, really powerful. It snips up proteins. But pepsin, when it's produced, is produced in an inactive form called pepsinogen. It's actually longer. The protein is 44 amino acids longer than the active form, because think about it from an engineering standpoint. The last thing you would want a digestive enzyme to do is to turn on in the cell that produces it. Because the first thing it's going to do is say, wow, I'm going to eat this baby right now. There's a cell right here that's looking pretty good, you know. You want to secrete the digestive enzyme in a safe form into the stomach, where then it can be activated by snipping out those 44 amino acids that come out of the active site, turn it on, now it can do its job. Now, guess what activates pepsin? Turns it from pepsinogen into pepsin. What's part of the story? Come on, think really clever. Pepsin itself, it's autocatalytically activated. The hydrochloric acid helps to do the job. It opens it up a little bit so you can get those 44 amino acids out, but it's a really elegant solution to an engineering problem, which is digestive enzymes are enormously powerful, and you want them to work only where they're in a mucous membrane, like the stomach, well insulated, and the damage they do is the damage they're intended to do. So I look at the digestive system, as you've just pointed out, and I say it points to intellect. Some cause capable of seeing all the pieces necessary and putting them in place to perform a particular specialized function. I would never want to have to explain the origin of digestive enzymes from a Darwinian standpoint. Because natural selection actually has to go past the active protein and build a bigger one that's not active. It's a bigger molecule. And then, I mean, it's hopeless. Let me take your first one, though, about the fossil record. One of the things I work on professionally is the Cambrian explosion, the origin of animal form. And there, it's a dramatic signal. This is talked about in Steve Meyer's new book. It's one of the reasons it's so interesting. You've got basically nothing, a few sort of anomalous enigmatic forms like the so-called Ediacaran fauna. It's not clear what they are. And then, boom, 530 million years ago, this tremendous explosion of animal form with no fossil antecedents. Darwin knew about this. It scared him. That's why the book has the title it does. Because Darwin said, if this problem is not solved, my theory will absolutely fail. And here we are 150 years later, and the problem is much worse. So my philosophical ending, which I didn't get to because I wanted to leave time for questions, was if science is being held back by a rule that says you have to look for a natural cause, physics-based cause, when the evidence appears to indicate intelligence, that's a rule that needs to be put to one side. And we do this. We change the rules all the time for different things that humans do. I mean, I'm a big hockey fan. The NHL in the 80s was very boring. Okay, so they got rid of the two-line. You could have two-line passes. They got rid of holding. They changed the way goalies could perform. The game now is much more interesting. The game of science would be much more interesting without this dumb rule that you have to look for a natural cause come what may. Because I think the evidence of development points clearly to a cause with a mind. And I want the freedom to be able to talk about that.
Amen.
Thank you. I had a question on macroevolution and transitional fossils. On both sides of the intelligent design debate, it seems like one side will say, well, there's no examples of any transitional fossils, and then the other side will say, yeah, we got Archaeopteryx and Ambulocetus and Longus squama, and they'll keep putting ones. I wonder if there's any consensus on a definition both sides agree on of what a good transitional fossil would look like.
That's actually a problem because there isn't any consensus on that. The problem with fossils that I find is that they're kind of mute witnesses in the sense that you could never really have a criminal trial if the person you put up on the stand couldn't speak and couldn't even nod yes or shake their head no. Now, fossils, with respect to, when you compare them to forms that we have the complete organism and all its molecular data, fossils are actually relatively depauperate as sources of information. And it doesn't give me much confidence in the status of something like Archaeopteryx to see it come in and out of the history of birds. Right now it's out. It's on a sideline. When I was a student, it was right there in the center of the story. So I tend to be skeptical in general of the use of fossil evidence in building these trees because it's hard to evaluate their accuracy. I would say, though, the overall signal is absence of so-called transitions. Certainly at the major events like the Cambrian explosion, the mammalian radiation, and so forth, you have a lot more diversity appearing very quickly with almost no historical signal in the fossil record. I wish we did have an agreed-on definition. It would make it much easier to have a coherent debate.
Yes, I'm here to ask for advice and encouragement. My daughter will be getting her undergraduate degree in biochemistry in a year or so, and my unbiased opinion, I think she's very talented. But she looks at the opportunities out there, and of course the biggest funding that's available in the biological sciences are tied to the forced belief that evolution caused everything to happen. And so I guess the question is, what would you say to upcoming students as far as directing their career? If they're focused in this area, what kind of areas are open to them to get funding to do real research that could be useful to people?
Well, I do think I can offer some encouraging words, and the first thing I would say is what I was told by my advisor, my PhD advisor at the University of Chicago, which was advice I've never forgotten. He said, "It's unfair, Paul, but you're going to have to be a better evolutionary biologist than all the other students if you're going to hold a dissenting opinion." And he said, "You're going to be held to a higher standard. Just learn evolutionary theory a little better than everybody else and you'll be fine." And they gave me a full fellowship all the way through to my PhD. And in my experience, the young people I know who have successfully negotiated their graduate training and gone on to postdocs and so forth, they just work a little bit harder than everybody else. They use evolution instrumentally, and for that purpose, it's wonderful. There's a lot of evolutionary biology that's perfectly well supported and belongs in the toolkit of any biologist. It's not fair, but that's life. You hold a minority position. You're just going to have to prove yourself to be a better student, but maintain your intellectual independence. And so that's one piece of advice about just work hard and you'll be fine. The other piece of advice is there's a lot more dissent out there than people realize. A lot more. And, when I was a kid, I remember reading Solzhenitsyn as a teenager. and thinking we'd always have the Soviet Union. It was impregnable. You and I are probably about the same age. I might be a little bit older. It seemed like it would always be there. And 1989 to 1991, it went down overnight. The level of dissent from Darwinian theory is much greater in the biological community than anyone realizes. The problem is there are a lot of bullies who keep people in line. Just the way that as the Soviet Union was winding down, there were bullies who kept people in line until they couldn't do it anymore. But at Discovery, we know a whole network of very good professors, many of whom your daughter might like to work with, in fact, who dissent, but they're very cautious about it. I'm not making any predictions that Darwinism is going to go down overnight, but don't be surprised if it does. Don't be surprised if it does. I mean, I tell you, it was one, to see Yeltsin standing on a tank and know it's all over, that was pretty amazing. Yeah.
I had a question on your macroevolution chart showing that the embryo takes different paths and stages.
Yeah.
And you said in order for macroevolution to work, you have to have a mutation early on.
Yeah.
Otherwise, it won't affect as many. I was wondering, wouldn't it be possible that near the end of the development, there was a small mutation that would allow the embryo to still survive and change a small portion of it? And then in turn, that mutation and change would allow a different mutation to be survivable at that same stage.
Yes.
And in turn, time after time, given long enough, wouldn't it be possible to change an animal pretty...
No, you're right. In fact, that's in fact where we do see many of the mutations that are viable are expressed late. But if you remember that diagram, because of their position as the embryo is developing, that mutation will affect only a relatively few number of cells. It won't affect the global form, the overall architecture. So for us, we have to have a brain stem. We have to have a heart. We have to have lungs. We have certain non-negotiables to be alive at all as Homo sapiens. The fruit fly anatomy, when you look at where the basic axes are set in place, saying what's your head, what's your tail, what's your front, what's your back, the sort of the global form, it's set in place when there is a single cell. And the mother puts in molecules that set up gradients that tell the fly head, tail, front, back. It's that kind of mutation that you would need to change the overall form. Lots of small-scale things can happen, as you point out, but the problem is they're small scale. They affect rather small parts of the architecture, like bristle number, wing venation, and so forth. But we have mutated fruit flies just about every way imaginable since the first decades of the last century. And the signal that comes back from fruit flies is if you want us at all, we're going to need 3 body segments, 6 legs, and so forth. You get normal flies, sick flies, dead flies. That's it. They're all Drosophila. You don't see anything dramatic. Nature talks back to us, and she gives us a signal, and it's our responsibility to listen to that and modify our theories accordingly. And I've run over. Thanks for being so attentive.